There is a cone of radius r and height h is kept on turntable. This is a turntable. And here we can call this is turntable. And this is a cone. This is a cone. This everything is a turntable. Some rough diagram I'm showing it. Try to analyze. Then the distance between the axis of cone and the axis of turntable is r. Okay, this distance here is given. The maximum value of omega for which the cone does not topple. So it should not tilt. What are the forces they'll be acting? We'll analyze the forces. First, centrifugal force. Then next again, the normal contact. Afterwards, जो समुद्र है this is about the mg. Okay, these are the forces. Friction is sufficient. Okay, that friction will show like this. The arrow will show it. And this is mg. This is a normal contact. This is p. And this is centrifugal force. Mass of the cone is m. Then why the normal contact will shift here? The cone is having ability to topple about p. How do we can decide that? About center of mass, the torque due to centrifugal force and mg will be zero. The torque due to friction will be clockwise. Then tell me like a who should balance if the cone doesn't topple? Then definitely the normal reaction will not act here. In fact, will shift and will act through this point. Since we are asking maximum, so therefore I'm assuming normal contact to be here. We are discussing just about to topple about P. Once again, I'm repeating about center of mass, torque due to centrifugal force, zero, because it will intersect axis of rotation. Torque due to weight will be zero, intersects axis of rotation. Torque due to friction will be clockwise. Then who will balance torque due to the friction? The torque due to normal contact. It should be like this. We'll show everything to the torque due to friction. Torque due to normal reaction. And rest on everything. Okay, these are the centrifugal forces like this. So the net torque about center, about point P should be zero. So, okay, now your task questions are what are these like? See, these are like a, either you can choose the, this one bit since we wanted omega, no? We wanted omega. Therefore, why I'm showing all this torque due to normal contact and friction is to tell you that the normal contact will shift. If the normal contact doesn't shift, we'll assume that one. Normal contact will not shift. Let it act here only. Then will balance torque due to friction. So therefore, for that purpose, the normal reaction will shift. Will vanish. let's come for all the things. So we'll go for these forces. We'll try to discuss about point and is telling that this particular frictional force sufficient to balance this, to balance this one. So definitely what we can expect here, the with respect to rotating turntable, with respect to rotating turntable means you are standing somewhere here, or the state of the cone will be at rest. No, all will set up the torque above the point P. Centrifugal force. For a cone, what should be the side? H by 4. So we'll indicate that in the diagram. And this distance will be R. We'll write down. Net torque about point P should be 0. Torque due to centrifugal force. Torque due to mg. Torque due to centrifugal force will be H by 4. Torque due to mg will be mg into R. So we'll simplify this. M will get cancelled out. So omega square H by 4 plus G. Omega is equal to if the angular velocity is greater than this, it will topple about point P. If the angular velocity is less than this, the block will not topple on the turntable. This will be your answer. Huh? A simple idea. So what is this m omega square r? It is about the centrifugal force. And what we are discussing, toppling due to centrifugal force. That's a basic idea of the problem. Huh?